Let's see this question. This question is asked in GATE 2013 in the subject control systems. Okay, this is the linked question. Linked question in the sense they will give the same data, they will ask one question, and in the next question, based on this answer, they will carry forward to the next question. Now we will see this question. The state diagram of the system is below. Okay, a state diagram is described by the state variable equations. So these are state variable equations. Okay, they have given one diagram. Now the state variable equations of the system, which we need to find it out in terms of matrix form. Okay, now from this diagram we can write let this can be x1, this is x1 bar, x1 dot, this can be x2, this can be x2 dot. The reason why I put dot, because here x1 dot is nothing but d by dt of x1. Okay, the differentiation with respect to time gives rise to x1 dot. If you observe here 1 by s, which means integration. Okay, integration. If you are performing integration and differentiation will be get cancelled and finally left over with x1. So we can write here x1, x1 dot, here x2, x2 dot. From the above graph we can write, from above graph we can write some equations with respect to x1 and x2, x1 dot and x2 dot. X1 dot is equal to, x1 dot equal to, you observe here u multiplied with 1. Okay, u multiplied with 1 and added to x1, added to x1, whole thing is multiplied with minus. Okay, whole thing is multiplied with minus 1. So this is equal to x1 dot. X1 dot is equal to u multiplied with 1 added with x1 whole multiplied with minus 1. Now this x1 is equal to u into 1 u plus x1 multiplied with minus. This gives rise to minus x1 minus u. Okay, this will be the x1 dot. This can be equation 1. Similarly, you can write x2 dot equal to, x2 dot equal to, see here x2 dot, you take x1 dot multiply with 1, you take x1 dot multiply with 1 and add to x2, add to x2. Okay, and this whole thing is multiplied with minus 1, whole thing is multiplied with minus 1. This gives rise to x2 dot. If you do this equation, this will be minus x1 dot minus x1 dot minus x2. Okay, minus x1 dot minus x2. This can be equation 2. Right, I am writing these two equations here. Okay, x1 dot is equal to, x1 dot equal to minus x1 minus u, minus x1 minus u. X2 dot equal to minus x1 dot minus x2, minus x1 dot minus x2. So substitute equation 1 in equation 2 in place of this x1 dot. Now x2 dot becomes minus of minus x1 minus u minus x2. This will become minus into minus plus x1 minus into minus plus u minus x2. Okay, this is our new x2 dot. Now we can write these equations, what is this equation 1 and this equation 2, in terms of matrix form. So represent above in matrix form, matrix form. So represent above equations in matrix form. We will get x1 dot x2 dot, okay, is equal to, here for x1 there is minus 1, there is no x2 component. Here for x1 there is positive, if you observe this and this. Okay, and x2 is minus 1. Okay, multiplied with x1 x2 and plus, and we need to get u component also. Here it is minus u, here it is plus u. So minus 1 plus 1 into u. Okay. This is in the form of x dot equal to ax plus bu, where a equal to minus 1 0 1 minus 1. Okay, and similarly b equal to this 1 and minus 1 and 1. Now we write the same equation for y. Y is here. Y is equal to x2 dot into 1. x2 dot into 1. We can write x2 dot into 1 is same. Okay, x1 minus x2 plus u. This equation can be written in matrix form as y equal to 1 minus 1 into x1 x2 plus u. Okay, so in the options, if you observe here, you can write the same thing as plus 1 minus 1 into x plus u y. Okay, so we have got the answer. This thing, this is the first thing, this is the second thing. If we compare, x equal to minus 1 0 1 minus 1 into x plus minus 1 plus 1 into u, and y plus 1 minus 1 x plus u. So option A is the correct answer. This is the second part of the question which we have solved earlier, and earlier we have got these things. Okay, now the state transition matrix e power at of the system shown below. Okay, now they were asking to find state transition matrix. State transition matrix e power at equal to phi of t. Okay, this can be written as inverse Laplace transform of si minus a whole inverse. Okay, now we will try to find si minus a, and si is s0 0 s minus a is minus 1 0 1 minus 1. This is a simple matrix subtraction. You can write s minus of minus 1 as s plus 1, then 0 minus of 0 will be 0, 0 minus minus 1 will be minus 1, s minus of minus 1 will be s plus 1. Now you find inverse of this 2 by 2 matrix, si minus a whole inverse. You know that 2 by 2 matrix inverse will be, if a b c d is the matrix, the inverse will be 1 by ad minus bc into d minus b minus c a. The same thing you apply here. Okay, 1 by ad minus bc s plus 1, okay, into s plus 1 minus ad minus bc. Minus into minus will be plus 1. Okay, this will be 0. Minus 1 into 0 is 0. Okay, now d is this thing, b this thing, d minus b minus c. D minus b minus c becomes minus of minus 1, and a is s plus 1. Okay, this will be 1 by s plus 1 into s plus 1 is s plus 1 whole square equal to 1 by s plus 1 whole square. Anyway minus 0 we can neglect. This will be s plus 1, this will be 0, this will be 1, this will be s plus 1. So you multiply this term with the elements of the matrix. We will get, write down here only, after multiplication this will be 1 by s plus 1, this will be 0, this will be 1 by s plus 1 whole square, this will be 1 by s plus 1. Okay, this is the term we have got by solving si minus a whole inverse. Now substitute that thing in this equation. Okay, now e power at is equal to phi of t, that is state transition matrix, is equal to inverse Laplace transform of 1 by s plus 1 0, 1 by s plus 1 whole square, 1 by s plus 1. We know that Laplace transform of 1 by s plus 1 is e power minus t. Inverse Laplace transform of 0 is 0. Inverse Laplace transform of 1 by 1 s plus 1 whole square is t e power minus t, and this will be e power minus t. Okay, this will be state transition matrix. If you observe in the options, e power minus t 0, t e power minus t, and e power minus t. So option A is correct answer.